Laser Scanning 101. Introduction. So what is the purpose of this lesson? I've noticed a big gap in laser scanning training and the overall workflow with scans. So when I first started in the engineering business, I had very little to no training on laser scanning. I didn't even know what it was. I tried to go on YouTube and Google to see what was out there, but there wasn't really much. I came across a laser scanning forum called laserscanningforum.com, and I tried to read and learn laser scanning. I felt like I was reading text on a page, but not really understanding what people were talking about. I think the main reason for this was people on this forum assumed you had some experience with scans. The forum was very little in terms of help in the beginning, but it was moderately okay with some experience. But the forum is filled with sales reps and very little knowledgeable designers that actually work with these tools. When you're at an advanced level, the forum isn't really helpful either. The purpose of this lesson is to start from the ground up and then tie everything together. I could not find a single lesson or document anywhere that ties everything together from the beginning of an engineering project to the very end. So who am I? I am currently working as a piping designer for a major engineering design firm in Canada in the oil and gas business. My main focus at work is brownfield work, which means replacing kind or replacing existing. Replacing kind is really straight replacing kind. There are always modifications. We have to bring the existing up to code. So that's why there's always modification. And replacing kind is really just replacing kind. It's more like replacing kind and then improve on the existing to bring up the code. So in contrast, what is greenfield work then? Greenfield work is new construction, which is easy. You have a piece of land, you have nothing in the way or anything you have to really avoid. Brownfield work is hard. Space is limited, and it seems like everything is always in the way. So how has laser scanning helped change the business? We have reduced the number of hours in engineering and other stages of the project, like time spent on field checks and then class resolution. Thus, more focus can be on detail engineering. We have reduced engineering clashes because now we can see the existing and pull measurements from the scan dataset. We have increased productivity. We have reduced the field checking time since we have brought the field to the office. We have reduced field construction costs due to design chain clashes detected by clash detection and visual checks during model reviews with the embedded laser scan. Objectives. The first objective of this lesson is to gain general understanding of laser scanning. This will not teach you how to scan or in detail how to use software associated with it. The next objective is to get the general tools and workflow pertaining to laser scan in detail engineering from project inception to the final deliverable. So what is laser scanning? Laser scanning uses a beam of light. It shoots it out to figure out where something is. So it can produce 100,000 to 1 million points a second depending on what scanner you use. And depending on what type of scanner, long range, short range, etc., you can achieve millimeters of accuracy. The scan can come in black or white or in color. From my personal experience, I don't really find color beneficial. It's nice in terms of it's pretty and all that kind of stuff. It's good for presentations, but workability, black and white is better. You see more of it, it's more dense, and also the size is 3 times smaller compared to color. Laser scanning also provides us with a 360-degree point of view. So in this demonstration, you can see the scanner picking up objects in the room and then generating points. The point cloud data is slowly getting captured by the scanner. Keep in mind that the scanner can only see what's in front of it. It cannot pick anything up that is not in its line of sight. So what does it mean? It means that it can't see things behind the desk. In order for you to get things behind the desk, you have to scan in multiple locations, overlapping each other, and then stitch them together to get the entire room. Overall scanning workflow. The first step is the access step. This is the planning stage. This is where you define the goals of the project. Are you replacing kind? Are you expanding based on the existing? So if you are, what are you trying to avoid? What we want to really make clear too is I think people have a different definition of laser scans, as in some people refer to them as models. It's not a model. It's a point cloud, millions and millions of points that shows the existing. It's not a model. So once you have this point cloud data, what do you do with it? Now you can try to upload or download the data, but the problem is the scan can be 50 to 300 gigs depending on level of detail, what type of scanner you use, what kind of software you use to export it, and also just color, black or white. If it's in black and white, it's going to be smaller than color. Once you try to upload or download these huge data sets, you run into a problem where you might have upload failure or incomplete uploads. Or on the other side of it, let's say that you can upload it. What if you have issues downloading it? You're trying to download one file that's possibly 50 to 300 gigs. What if you don't download it completely? It's just a lot of probability for error. So the best way to transfer all of these files is still by hard drive. So the next question is, who scans? Internal or external? Do you do it, or do you give it to someone else to do it? And from my personal experience, I find that most engineering firms contract out the scan. It's because most do not have a surveying department, or they don't have that expertise. Their expertise is in detail engineering these things, not surveying. Also, another thing to keep in mind too is that the overhead costs for the laser scanning equipment and software is extremely high. So unless you're actually scanning day in and day out, it's not really worth it. The next step is to scan. So the scanner will pick up raw data and it will go into a hard drive. After when they have the raw data, what they have to do is they have to register it, which means they're stitching and combining the raw data files. Typically what happens is the surveying company will have markers taped on the location where they're scanning, or they have associated software within the scanner or outside of the scanner to combine everything together. Once that's all stitched up and combined, you want to give it coordinates. Once you have it set to where it is in relation to real life, now you can index it, which means you're exporting that to a usable format. Two formats that I've used based on my experience that are popular are recap files, RCP, and LFM. After when you have it indexed, now you can begin using your design software to model. So that can be Plant 3D, that can be Revit, or anything like that. So in this demonstration, you can see the existing, which is in gray, the new stuff, which is in magenta. In this particular case, what we're doing is we are expanding and combining the platform. We are removing the existing via bolt-up connections at the top of the vessel after the elbow, and then we're squeezing in more stuff in place of the existing. We have to do it this way in a way where we are avoiding the existing or designing around the existing. In brownfield work, space is always an issue. putting it all together. So this is from an oil and gas piping designer point of view. So for me, the exception, most clients has already done a study of the proposed expansion or revision of the design for the unit, either to increase productivity or safety. The green light has already been given to begin detail engineering. Then it comes to field checking. You gotta field check to establish tie points. You gotta have a general understanding on the general layout, set the project benchmark where you're gonna work on, and then now you're gonna pull tape to measure and sketch out the existing just enough for the project. You don't want to do too much. You also don't want to do too little. You want to do just enough. If you do too much, you're kind of overlapping your work that's already been done by the scan, but you want to do just enough so then you kind of have an idea of where the scan should be. Laser scan scope of work. The purpose of the laser scan scope of work is to tell the guys where and what to scan. So here I usually pull a plot plan or a steel drawing to give the guys a reference point where to scan. I usually highlight or color the area on the plot plan or steel drawing that I want to be scanned. Now you want to start modeling the existing based on your field notes, and then design new preliminary based on what you have while waiting for the scan to come in. Modeling the existing is critical for pipe stress calculations and fitment of the new design. So basically what we're trying to do is we're trying to establish the boundary of the project. In this step, it's a balancing act. You don't want to go ahead too much without the scan because then things won't fit. But also, you don't want to do too little and be behind. You have to do just enough to establish the existing and have an idea what the new design is going to be, but also design it in a way where it allows for future possible changes. Now, there are software out there like ClearEdge that will help you recognize and auto-generate the existing into a model, but usually it's not really feasible. The reason for this is that design software can be very expensive, so unless you're actually modeling the existing extensively, it's not really worth it. Once you have received the scan, in this step, you always want to check the scan for the project data point accuracy, because sometimes the scan can be off. So how do you do this? So remember how you model the existing based on your field notes? Now you can overlay the laser scan to see if your stuff fits. If it matches, you're good. If not, now we got a problem that we have to address. Once everything fits and you have verified that the scan is good to go, you have to adjust your model. That's always after you have verified the project data point, of course. You want to revise the existing and the new design model. After that, you have model reviews. So generally, most people use Navisworks for model reviews to walk around. Laser scan in RCP, recap, can be embedded for model reviews. This is a great opportunity for a client and other disciplines to comment regarding egress and possible clashes, operability, etc. Clash detection. Now, clash detection with laser scan is possible through Navisworks or software like LFM. Keep in mind that this is all visual. It would never be 100%. I have found that Navisworks is superior for data reporting, so exporting a report, whereas LFM clash detection is good for detailed engineering, not for reporting clashes. So what do I mean by this? LFM will not give you the entire picture. It will only give you detail in a focused area because you have to tell it where you want clash detection done. Clash detection with raw laser scan in Navisworks isn't really the most effective either, unless the scans are converted to a mesh, like solid. Without that, we're really clashing with millions of dots, not really a service, so it is still subject to interpretation. Clashing with the mesh or solid generates a definite clash or a clear. Finalization. So in this step, the design, everything is complete. what we're ready to do is we're ready to give the client a single NWD with the embedded laser scan that can be delivered to the client via Publish feature in Navisworks. So now you're done, you're in the clear, everything's good to go. This concludes this lesson. I hope you found this useful and hope you see you in the next one.